SwayamPrabha. Digital India. Educated India.
Good morning everybody. So, today we will going to start the lecture number 4 in the module number 1 in the first week module. So, today we will going to discuss about the sound pressure and the intensity level. If you remember in the last 2 lecture, what we have discussed is that is the propagation of the sound. We also discussed the frequency and the octave band. So, now let us proceed further and let us know what is the sound pressure and how it can be measured and how that particular sound pressure and the sound intensity can be mathematically converted to the sound levels. So, in this lecture we have again 2 objective as a learning objective. So, what we will want to do in this particular half an hour lecture is that we need to convert or we need to know how to convert the intensity and the pressure to a particular sound level, and also we will like to know that how can this particular sound levels of from the multiple sources can be added and what will be the resultant sound level for that for the addition and all. So, here we need some kind of operation, some kind of a mathematical operation to know about, and these mathematical operations are well known to you, but that for the starting point of view, let us brush up those mathematical operations, and we need here some logarithmic operation. In the logarithmic operation, the first operation is something like this, which is also you know, that is log a. If it is x, then 10 to the power x is equal to a. The next operation what we also need is that if the 2 log terms are added, suppose log a plus log b, it will be log a b. The third operation what we need is that is a subtraction from one to another log, that is log a minus log b will be a reciprocal, that is the log a by b, log a by b. And the third or the fourth one and the last one what we need is that if log a to the power n is always equal to n into log a. So, these 4 basic operation of log will be required to understand the basic principles of the sound pressure level and the sound intensity level. Now, let us know how we actually hear, human hearing. So, what you see in this particular board is that the cross section of human ear. You must have seen this particular cross section of the human ear in your school days, in your biology book. So, here as we understand from the first lecture is that sound is a wave transmission, and that wave transmission gives in the air in a multiple layer, which will some layer will be compressed and the next layer will be refract or the extend, and it will move from one point to the other. So, when it moves from one point to the other, the wave propagation towards the, if it is towards the air, it will enter into our ear, and how it will actually sense the brain, let us discuss that. Suppose this is the air cross section, the similar air cross section, and it has some parts. So, these 4 parts or maybe the first 3 parts are called as a the outer air part, which is has a pinna which is like this, and then there is a auditory canal over there, and then auditory canal is actually terminated to the eardrum. And if there is a particular propagation, and if I am showing it in a flowchart diagram, the external air, that is from here, the pressure which followed by follow the path of the auditory canal, and it will strike to the eardrum, and the total pressure of that particular channel or the canal, auditory canal, is equal to the atmospheric pressure plus the sound pressure, the P atmospheric plus P s, and it will strike to the eardrum. And there is another canal or another tube that is there in through our mouth to the canal, So, that is called as the Eustachian tube, and this Eustachian tube will only take care of the atmospheric pressure, and it will also proceed to the eardrum. If you see, I have animated a bit this particular the red arrows are the pressure from the air pressure, that is the atmospheric pressure, and the sound pressure, and another the yellow arrows from the Eustachian is the only atmospheric pressure. So, the eardrum basically under two different pressure scenario, one is P atmospheric and plus P sound, and from other side it is P atmospheric. So, finally, the eardrum will vibrate because of the resultant pressure of that is the P sound pressure, that is the two mutually perpendicular and on opposite directional, not perpendicular, mutually in a linear and opposite in direction. So, the sound pressure will, the P s will actually vibrate the eardrum. What happened in the next operation is that, so this eardrum is connected by the three middle ears very small bones, and there are three bones, malleus, incus and stapes is linked one after another, and that is actually transmitting the transmitting that particular the three ear bones to the cochlea, and cochlea is full of some liquid or so. So, what happened is that when this eardrum is vibrated by the sound pressure, it will going to vibrate the middle ear bones, these three bones, and there is a micro amplification, micro mechanical amplification I must say, because this is a three bones are hinged together, and it will be the amplify the thing, and it will be actually impulse has been provided to the cochlea. And these three are the bones and the cochlea are called the interior part of the ear, and then finally, cochlea sense that, and then it is the behind the cochlea there are auditory nerves. So, there the cochlea sense that particular vibration from the three middle ear bone, and it provide the some mechanico electrico kind of a conversion, the mechanical to the electrical conversion, and this electrical sense of pulses through the nerve it will sense in our brain. So, this is at a go we can actually again see that particular flow chart. So, this is the eardrum vibrate by P s, that is the pressure from the sound pressure, then middle ear vibrate, micro mechanical amplification gives to the cochlea, from the cochlea mechanico electrico conversion, and then it is going through the auditory nerve to the brain. Now, next is let us see the how the brain and our sensation of the sound is perceived by the brain. A psychologist Weber suggested this particular phenomenon or this particular proposition, that is a subjective response is the function of change of stimuli, is proportional. So, if it is proportional, so if it is something like the change of response is R, this response may be the weight, this response may be the light, there is a slight change in the light, whether I can identify that particular change or not. If there is a weight in my hand, I just increase a little bit of extra weight, can I sense that one? That is the stimuli, the change of the stimuli, and the R is the sense. So, mathematically it can be expressed as the change of R is equal to change of stimuli by the initial stimuli, that is the cap S. If I integrate then this two side, then I will get a mathematical expression like the R is equal to log of S, and there is a integration constant as C, and then further this integration constant C can be clubbed into this logarithmic part also, and then we can write that R is equal to K times log of S. So, this is a particular way the human being sense for weight, for any scenario like a light or maybe temperature or maybe the sound. And we see that in the sound, in case of the auditory case, auditory sensation, we can sense the very minute change, not in a specific way, but if there is a change in a bigger order, then it may be sensed in a better way. And this particular change is very much adapted or very much sensible if the frequency or the level of the sound is in a lower order. This particular change, the same change if it is in a higher order, we may not sense that one. So, that is why we can say finally that a human being or we hear logarithmic. So, the expression of the sensation, that is the sound pressure or the sound intensity, finally translated to a logarithmic scale, and that will give us the sensation what we have just now discussed or the see from this particular Weber's proposition. So, let us discuss about the limit of audibility. The limit of audibility is as we define as the suppose as the sound pressure is fluctuating due to the propagation of the sound, and this pressure fluctuation of the sound is either above the atmospheric pressure or sometimes it is below, and that particular sound will create a sensation in the human ear. So, there is a minimum amount of pressure that is required to be sensitized our the brain to create a sensation of the sound, and that is the that minimum pressure is 2 into 10 to the power minus 5 Newton per meter square. So, when this much of the minimum amount of this pressure is present in a particular sound propagation, we start hearing, and that is the initial point of our the sensation starts from the hearing point of. If anything below that, the pressure is below that, we cannot actually hear that particular sound. So, this particular point is also equivalent to, suppose now if I want to equivalent that particular pressure to some kind of a intensity of the sound, which is actually measured in the watt per meter square, the equivalent intensity will be required for just to hear is 10 to the power minus 12 watt per meter square. So, below that intensity a human being cannot the sense that particular sound. So, this particular point where this bottom line where the particular sensation of the hearing, the audibility starts, is called threshold of audibility. Now, if I increase the pressure, or as I increase the pressure, the intensity is also going to be increased. So, definitely the sensation also will be increased, we feel more and more sound, more louder sound or something like that, and finally at a certain point it creates some kind of this discomfort. So, on that particular level is corresponding to the sound pressure level is 20 Newton per meter square, and from the intensity point of view it is 1 watt per meter square, and that particular point is called as a threshold of pain, because that is the maximum sound, or I can say it is a minimum sound that is this, or it is the starting point of any kind of the auditory discomfort. We may also hear another 10 to 12 or maybe 15% excess amount of sound from this pain point of view, more than that pressure or maybe the intensity, but that will be real discomfort for our ear, and also it will be create lot of damage to our ear on the ear drum or all those kind of a part. So, next let us see this particular in between this threshold of pain and the audibility. If I want to find out that particular how this particular the intensity can be converted to a sound intensity level or any kind of a measuring level. So, we will take the help of this particular equation, because already we know that a human being hear in a logarithmic scale. So, if suppose there is a sound level somewhere in between which is given by I, and the I reference is the bottommost, that is the threshold of audibility, that is 10 to the power minus 12 watt per meter square, that is the I reference, this is the I reference. So, I can find out the logarithmic of I by I reference, and if I can find out this the logarithmic of this ratio, this is the sound intensity level in bell, and if I just multiply that by 10, then that is the decibel, and that is the unit of sound intensity level or so. So, please remember the actual sound level divided by the basic or the reference level. So, now in the next, if I see if in this, if the sound the intensity is 10 to the power minus 12 itself, then this ratio become 1 and log 1 becomes 0. So, the I can say at the threshold of audibility the decibel, it is 0 decibel actually. And if I go to the highest threshold of pen, this equivalent to 1 watt per meter square. So, instead of I put the 1 and this became same 10 to the minus 12, that is the reference value. So, this ratio and the logarithmic of that multiplied by 10 gives me 120 dB. So, the decibel level fluctuates between the 0 to 120 dB from the audibility to the threshold. Next, let us go to, if I can again rewrite this equation or rewrite this particular concept in power level. What we just now discussed is the intensity, which is watt per meter square. Now, if I want to see it is how much power, watt, then again these limits are of 10 to the power minus 12 watt to 1 watt, and I can express the sound power level as 10 log W by W reference, where W reference will be the threshold of audibility in 10 to the power minus 12 watt, and W is whatever may be that actually which that particular sound I am going to measure its own power. So, similarly, in the same fashion I can say it is also fluctuate. If I express this into the power level, it is 0 to 120 dB, 120 dB refers the threshold of pen and 0 dB refers the threshold of audibility. Now, again go back to the pressure, where I have told initially that this pressure is also fluctuating between 2 into 10 to the power minus 5 Newton per meter square to 20 Newton per meter square. If you see both all the three cases, this is a huge difference actually. The last two cases, it is almost about 10 to the power 12 times the lower and the minima and the maxima from the pen to the audibility, and here it is almost about 10 to the power 6 times from the threshold of audibility to the pen. So, it is better to take the logarithmic scale and make it little bit of the sizable amount to justify or the measure the pressure level. So, here in this case, if I know the pressure of the propagation of the sound in Newton per meter square, then I will use this equation. The sound pressure level is 20 log P by P reference. As usual, P reference become my 2 into 10 to the minus 5 Pascal or Newton per meter square, and any sound that has some the pressure of value P will be my this P, the actual sound pressure P in Newton per meter square. But please remember this equation, there is a slight change in this equation with respect to the other two. It is actually 20 log, not 10 log. Why it is 20 log? Because the intensity and the pressure is related with like this. The intensity is proportional to pressure square. We will discuss in the lecture number 5 in this particular issue. So, as this is so that is why the SPL, that is the pressure level, is 20 log, not 10 log. Now, again let us see how this SPL is changing. So, if I have almost the same, that the threshold of this audibility 2 into 10 to the minus 5. So, this log 1 gives me 0 decibel, and if I put 20 as P and P reference is this 2 into 10 to the minus 5, then I am getting this particular ratio into logarithmic and multiplied by 20 as 120. So, this 0 to 120 from the threshold of audibility to the pen remains same, there is no change in that. Only the change in the physical parameter. Sometimes I am calculating by virtue of the pressure Newton per meter square, sometimes I am calculating by virtue of the energy or the power, that is the watt, and sometimes I am measuring that particular the sound intensity or level in terms of intensity, that is the watt per meter square or so. But final result will be in dB using these three equations or so. The why decibel? Why decibel? Because we everybody knows the Alexander Graham Bell, on the honor to his name, honor to his scientific development in our the world community. We have or the scientific community has proposed the unit of the sound pressure level as Bell or decibel. And in the left hand side you will see that particular instrument which is the sound level meter, and the sound level meter is used for the measuring the sound level, that is in decibel or so. So, I have a sound level meter with me, and if you see the sound level meter, it has a power button. So, you have to switch on the power button, and then there is a the range, you can set the range. we can set the range from the minimum to the medium to the maximum, and there is a microphone attached to this particular the arm on the top, and as you see I am speaking. So, this is going to give me some kind of the sound pressure level. Now, it is 65, 70, 68, 68, 62 like that. So, some sound it will catch, and then it will going to give you the sound pressure level directly. So, the sound intensity to the sound level conversion. So, now let us play with those formula and see how the sound intensity and the sound pressure and the sound pressure to the intensity or those levels can be taken into consideration. So, here in this slide we will discuss the sound intensity to the sound level conversion. So, as we know, this is the formula, the level L is equal to 10 into the logarithmic of I by I reference. So, I have a very small problem, that suppose the intensity is 0.005 watt per meter square, what could be the intensity. So, as you put it everything in the value, everything in this particular every value in the particular formula, and you get the ratio and multiply with the 10 log and multiply with the 10, and you get 97 dB, which is pretty high. Then the reverse order, the sound level to sound intensity conversion. So, the sound level to sound intensity conversion, you have the same formula, and from the formula you derive like then the log of I by I reference will be L by 10, because you see that if you just go with this formula, and then if it is I by I reference will be 10 to the power L by 10, and finally, I am interested to find out the I. So, the I will be equal to I reference into 10 to the power L by 10. I reference we all know that is 10 to the power minus 12, and L is the sound level, that is dB, how much is the decibel that you can put, and finally, you can find out what is the value of I. So, suppose SIL, the sound intensity level is 65. So, I will put 65 over here. So, finally, it is 10 to the power 6.5, and the I reference is your 10 to the power minus 12. So, finally, this is the watt per meter square, that is the intensity. So, I have listed down some intensity or the sound level in fact in the dB, just to give you a kind of a idea that what is the dB that exist in our day to day life. The sweeping of the dry leaves is very low level of or the sound, which is around 10-15 or so. A background noise in the television studio, where there is kind of a broadcasting or maybe telecasting is happening over there, we require very low amount of sound level, which is prescribed as 20 decibel. Library, very quiet area, bedroom, very quiet area, 30 to 40 is recommended. Residential zone recommended as 50. Now, normal conversation which we are doing now, it is more or less 60, we have seen in this sound level meter 60 to 70, it is fluctuating. Vacuum cleaner is a sound producing the equipment, which is if you in front of 1 meter of that particular vacuum cleaner gives you around 70. Heavy city traffic is 80. The pneumatic drill is very bothering sometimes, it is 90 to 100. The discotheque is a noisy area, very noisy area in fact, and it is almost touching to the threshold of pain, sometimes it is 100 to 110, and if it is very near to jet aircraft, around 100 meter near to jet aircraft, it is really painful, 140. Now, let us see how the addition of sound levels can be done. So, I actually have to encounter, or in any kind of a sound physicist has to encounter different sound level, multiple sound levels. So, here we will discuss how this two sound level can be added together and in a logarithmic way. So, sound level 1 is having a level 1 L1 dB. So, that can be translated to the I 1 as you know, that I reference by 10 to the power L 1 by 10, and there is a sound level 2 or sound source 2, which is have a level L 2, and that also give you a very similarly I 2 equal to I reference into 10 to the power L by 10 L 2 by 10, and this sound intensity can be added arithmetically, not the sound levels, that is the decibel cannot be added arithmetically. So, suppose there is a 60 decibel and there is a 40 decibel, you cannot add and say it is a 100 decibel. You have to actually transfer the 60 decibel to the intensity, its respective intensity, and the 40 to its respective, and then you add the intensity arithmetically and convert that intensity to the decibel. So, here also I have to now add this arithmetically I 1 and I 2, and then this I 1 and I 2 gives me a new I total, the new intensity, and then I will put it into that, and finally, the value will be like L. The total intensity is this, and the total level now will be, or the final level will be now will be this comes from the first part intensity 1, and this is comes from the second part intensity 2, and if you provide in the I total by I reference, you will get the total intensity. Now, addition of the sound level, again let us further say that if these two levels L 1 and L 2, which we have just now discussed, is similar. So, there are two sound source give the similar output. So, L 1 is equal to L 2 and that is equal to L. So, definitely the intensity of I 1 and I 2 also will be similar. So, the total intensity of the twice of I, and finally, it will give instead of in place of the total intensity is now 2 I by I reference. Now, we can separate it out, one is the 10 log of I by I reference plus 10 log of 2. So, what is this? What is this 10 log of I by I reference? It is nothing but the any one of the level. So, this is the level which I am going to add, plus 10 log 2 is log 2 is 0.3 and 10 log 2 is 3. So, if two sound source of equal in nature, equal output, equal decibel level is added, suppose 30 and 30 is added. So, the resultant will be 30 plus 3, 33. So, that is its what tells about. So, next we will see the sound, the addition of the sound. Addition of the sound also can be inferred from this particular graph, but how to read the graph? This in the x axis, it is the difference between the sound level is given, and the y axis the additional the add to the sound sources, it is also given. So, let us go to a small problem where I am adding a 60 decibel sound to the 65. So, by virtue of this particular expression, I got 66.2. Another example, I get 90 and 95, and I express that in the mathematical form, and I am getting 96.2. I am taking the help of the previous equation. Now, what I see is that in the both the cases it is a similarity. What is this similarity? 62.2, 66.2 is nothing but 65 plus 1.2. What is 65? 65 is the out of this to the higher one, 60 and 65, the higher one is 65. So, 65 plus 1.2. And what is this? 96.2 is 95 plus 1.2. 95 is what? The higher of these two. So, if the difference between the two level of sound is 5 dB, add 1.2 dB for the larger sound. That is actually translated over here. Suppose the difference between the two level of sound is 5 dB of my previous example, you go from the x axis to here and then you go here. So, add 1.2, 1 point, this is 1, this is 1.25, so 1.2 to the larger sound. So, if there are two sound which are equal in nature, so there is no difference. So, the higher and lower there is no difference. So, difference is 0. So, you have to add 3 dB with that we have already discussed in the previous slide. And if there are n number of sound sources, suppose it is not 2, there are more L 1, 2, 3, 4 more, then we can just rewrite this particular equation in a this way, and finally, with the summation sign we can find out the what is the total logarithmic and finally multiply by that into 10 to the L total or the total level. So, at the end of this this particular lecture number 4, let us have some homework for you. The first one is that the intensity of the sound, if it is 0.004 watt per meter square, and suppose another sound is of the sound pressure of 1.2 megapascal, can you find out the related sound levels? These two are not equal, but you have to find out for one also, you have to find out for the second one also. So, just go to the previous slides, find out the how to convert, and while converting you have to remember one thing, that is when it is intensity and when it is power. So, it is 10 log, and when it is pressure it is 20 log, and it is the intensity which I am going to take for finding the level divided by the threshold, that is for pressure it is 2 into 10 to the power minus 5, for intensity it is this thing is 10 to the minus 12. There is a second homework also. Suppose I have two different sound levels from two different source, one is 58 dB and one is 62 dB. So, if they are added, so what could be the resultant sound level? So, you have to do this thing by mathematical computation with the formula, do it by mathematically, and then check your result from the graph, that the graph we have discussed from that graph, and finally match your result. There are some bibliography, there are some books has to be referred for this particular lecture, and those are the books. You can find it in the library, or maybe you can go to the some library and get. Some books are available in e format also. So, thank you for joining in this lecture number 4. In the next lecture, we will go to that will be the last part of our acoustical physics, and we will discuss something on the near and far field propagation and also the loudness. Thank you.